Okay, we're going to work on breaking a vector into its component parts. So we've got the written description of a vector. A vector has a magnitude of 80 meters and is pointed, let's fix that a little, AD, and vector should have the arrow, north 30 degrees east. Okay, what does that mean? First, we are going to have to make sure we know our directions, and I know this is build our north, south, east, and west. Actually, I'm going to do that over here so it's a little smaller, doesn't take up all the room here. Okay, so in case you're unaware of it, here would be our north, our south, our west, our east. A couple ways to remember this. You can start with north, almost seeming like it's upwards, but never eat shredded wheat. You can always remember it spells the word we, and north is up, south is downwards. Whatever you need to do to remember your north, south, east, and west, stick to it. Okay, so now we're going to take our direction we've been giving, north 30 degrees east. Well, what that means is we start at north. So I'm going to take my line red here, make my line red, great, and that's currently north. And then we're going to move 30 degrees from there. So take our line, and let's say we start here. I'm going to show you what it's like to move it. And we're going to move approximately 30 degrees. I don't actually know, but this isn't the scale, but I'm going to say that that's roughly a 30-degree angle. And we moved in an easternly, remember this was east, we moved in an easternly fashion. Had it been west, we would have taken our line and we would have moved it in this direction because that would have been west, okay? Had this been southeast, we would have started at south, moved toward the east, and southwest, started at south and moved towards the west, okay? So they're usually written in this description of a direction for a vector, okay? So we have our vector and it has a magnitude of 80 meters, roughly 80 meters long, let's say. We want to break it into its components parts. Well, our component parts will actually deal with the two directions they've given us. We're going to break it into a component that is headed north and a component that is headed east. Okay, so what would the north and east components be? These two components would add together to create this original vector. Okay, so what does that mean? Well, we're going to build some triangles here. So we're going to take our first triangle here, and I'm going to draw to the north axis. If you're looking at two-dimensional space, this is usually referred to as the y-axis, okay? And I've built a right-angle triangle out of it. Wonderful. So we have our little right-angle triangle. We know that this is 30 degrees, which means that this must be 60 degrees, because that one was 90 in there, okay? And since we have the hypotenuse of this, and we want to find out what our north magnitude would be, we're going to use our, what do we got here? We know that this angle is 30, we're going to use adjacent. So cos 30 is equal to the adjacent, we're going to call it n for north, over the hypotenuse, which is 80. So if you don't remember your cos, it's cos theta is equal to adjacent over hypotenuse. All we did there is we said the theta, which was our angle, was the angle we were given, was 30 degrees. The adjacent side, so that's the side touching it, that's not the hypotenuse, was north. We don't actually know what it is yet. And our hypotenuse, which is this very long side here, opposite the 90 degrees, that was 80, okay? So now that we have that, we are going to isolate. We have it algebraically. We're going to isolate for our north. So this will become 80 multiplied by cos 30 is equal to the magnitude of north. And we know north is just pointed north, okay? We don't have to give it any direction there. So what is the magnitude of our component vector here? Well, the north vector will be equal to, get our calculator out. Okay, that's large as it becomes. I'm actually going to bring out the other calculator because I think I could fill a page. No, I can't. I lied. Okay. Clean out some stuff. Actually, it would have been a better calculator. No, we'll continue with this. We said it was cos 30 degrees, okay? And whatever that is, we're going to multiply by 80. And our north vector has a magnitude of roughly 70, 69.28. Okay, so 69.28 28 meters would be the magnitude of our north vector. How about our east vector? We said I had to break into two components, so I draw a right angle triangle again. Again, we know that this is a right angle. Because these two angles together would equal 90, I take a 90 and subtract 30. Well, what is that? That's just 60. And we look, we kind of got our Z principle here, alternating angles. I believe that was the rule back in grade 9 when you learned it. And here, this means this would be 30. So what we're really doing here is we're now just finding the other side of the original triangle we drew. You'll see this kind of looks like a rectangle now. We still have a hypotenuse of 80. We could still use cos to solve this. I'll use cos again since we used it the first time, and just to show how it's different, we're doing cos 60 this time. So cos 60 is equal to the adjacent side being east, and the hypotenuse still 80. So it's going to be 80 times cos 60 is equal to the magnitude of our east component vector. Go back to our calculator. Cos 60, okay, times 80 should be 40. Perfect. So the magnitude of our east vector would be 40. So in other words, if we're going to add vectors, I'm going to try to do this to scale as best I can here. 1, 2, 3, 4. We'll say each of those was roughly 10. Our east vector was 40 meters, headed east. And our north vector is roughly 70. It was about 69, so I'm going to say it's around there. Well, it's not bad, it's not bad scale. Say 69.28 meters. I'm going to say approximately 70 meters. If you were to add these two vectors together, we can get our component vector. Okay. So in order to add vectors together, the concept here is, I'm going to clone this one here. Okay. We're following the direction of the two vectors. So the first vector here was headed east. Okay. The second vector here was headed upwards. So from our starting point, this is our new ending point. Okay, and it is essentially the hypotenuse of a right angle triangle. We're saying that this vector is 80 meters long, which makes sense. The hypotenuse should be longer than the two legs of the triangle. And that this angle here would be 30 degrees, and we already know that the other one here would be 60, so this would be north 30 degrees east. Okay, so that's how you take the component vectors and add them into a resultant vector. And here's how we take the resultant vector and break it into its two component vectors.